Hi guys, in this video we're going to talk about sample space. We're going to dig more into that probability that I mentioned in the Venn diagram and tree diagram videos. And we'll start with what is sample space. So sample space of an event is the set of all possible outcomes. So we looked at that in that Venn diagram and tree diagram. We counted up those outcomes. So for example, when I flip a coin, sample space is the heads and tails. So you can think of probability as a fraction of the sample space, and there are two possible outcomes in that sample space. So the probability of getting heads is 1/2 or 1/2. And we talked about that in the last week's videos without really putting a name to that. I mentioned probability, but this week we're going to dig more into that. So this is just an example. A debate team has a competition, and Monica will give an extemporaneous speech for two judges. Each judges will either vote yes or no on whether she should advance to the next round. So our job is to figure out what is the possibility of that sample space. What are all the sample spaces we could have? So remember, we can kind of do a tree diagram on there. So if judge 1 has an answer and they say yes or no, then you could take judge 2's answers and they could be yes or no, yes or no. So all of my possible answers here could be yes, no, yes, no. They could also have a no, yes, or a no, no. So there's really 4 different ways that those two judges could have voted, and our sample space would be all 4 of those. So some more definitions we need that we're going to then look at. Are samples representative, or are they biased towards something? So a population, when you hear me say population, that's the group of interest, that's everybody included, and it's usually not possible to gather that data from each member of the population. Like if we were trying to get the vote of all United States citizens on whether they liked brown gravy or white gravy, we would have to survey millions of people. And there's no way to gather every single one of those responses, because how would you collect that? Would you call them? Would you email them? Would you mail them something? That's really hard to gather. So what you might do is you would sample a smaller group and see if we could get answers from that smaller sample to figure out those answers. And samples, of course, they're going to save us time. They're going to allow us to gather information and then make a prediction for all of the population. But they're only useful if they represent the whole population. Like if my sample for whether we like white or brown gravy is I only ask math students, then would that be representative of everybody's opinion? Or I only ask your grandparents. That is a biased sample. We would need to ask at least some math students, some of the parent generation, some of your grandparents' generation, to have a good representative sample. So we've got to find that representative sample that's going to be a portion of the population that is similar to the entire population. We don't want that biased sample. So we're going to kind of take a look at that now and decide, is our sample biased or representative? So Mara is questioning 41 members of the city's gym. Would that ever be a representative sample? Or is it going to be biased? Let's think about that. If she's at the gym asking them questions, no matter the question, is that really going to represent a good sample of the whole city? No, right? There's no way that if you go to the gym, you're going to get a whole demographic there. So that's a biased sample for sure. Whereas Albert researched 7 downtown districts throughout each county in his state, each county has an equal number of downtown districts. So if he researched 7 of them in each county, is his sample likely to be biased? And on this one, you might think, oh no, that's not biased. There is an equal number of downtown districts. But if we were looking at the total of the people in his state, then that would still be biased. We would only be sampling the local downtown districts. That's like if we said, okay, I'm only going to ask the people in Oklahoma City and Tulsa what they think about this, and we exclude the rest of Oklahoma. So that is still a biased sample. All right, so some simple probability, and simple probability is the ratio of likelihood or successful. We're going to use successful outcomes to the total, and I also like the word possible, the total number of outcomes. So remember, we would say probability of that is an event, sometimes called the A in this case because they've used A here, and that is a written fraction over total outcomes. Whereas the complement is the probability of the event not occurring. The complement is the probability of event not occurring, and the probability of the event and its complement add up to be 1. Add up to be 1. So on this one, we just write that fraction as not A when it doesn't happen over the total outcomes. So remember, make note of this. These are two good equations we're going to use here as we go throughout the rest of Unit 9. So let's think about that. If I'm predicting the probability here, Josephina is using the spinner below to determine the probability of spinning each color. So the probability of purple. So let's figure out, first of all, what is our total? We always need to find the total outcomes like we did on our tree diagram. Total outcomes are 1, 2, 3, 4, 5, 6, 7. So our fraction should be something over 7. All right, now purple only. Well, if there's only one purple, then we have a 1 over 7. Red or yellow. I believe the 2 box is supposed to be a shade of red, so that when there are 2 possible outcomes out of 7. Now here's a complement, not green. Not green, so all of the others except 5 could be spun to get a not green one. But if we want not orange or pink, then we have 2 of them that it couldn't be, and we would have 5 left over. So our probabilities here are 1 out of 7, or 1/7, 2/7, 6/7, and 5/7. What about this one? So if we roll a standard number cube or a die, remember there's 6 sides to a die, we're going to determine the probability of each of the events. So what is the probability I roll a 3? And remember, we're going to write that as a fraction over our total, which is 6. So a 3 only occurs once on one side. Not 4 or 5, so not this one, not this one. Leaves me 4 out of 6, but should I leave it 4 out of 6? Remember, we should always reduce our fractions when possible, and we can do that by pressing that alpha y equals on our calculator. Typing into our fraction, it will simplify it for us. Oh, sorry, I said 2 out of 3, and I wrote 2 out of 6. 2 out of 3, because they're both divisible by 2. Now this one, you got to read this as the number less than 4. So the only numbers less than, not equal to 4, are 1, 2, and 3. So 1, 2, and 3 gives me 3 out of 6, but if I simplify that, it's a 1/2 probability. But numbers greater than 0, that's all of them. Every one of those is a number greater than 0. So you would have a whole number, 1, which means you have a 100% chance of that happening. I hope these examples helped and you guys are feeling good about predicting this probability. Thanks for watching.